Hey guys, today we're going to take a look at negative exponents. If you'll recall, when we talked about exponents originally, we talked about how it's repeated multiplication. The exponent told you how many times to multiply the base as a factor, how many times to use it as a factor. Well, now we're going to look at negative exponents, which is kind of the opposite. Rather than repeated multiplication, it's going to be more like a repeated division. So first thing I want to talk about, sorry, there's a bug there, is how we write that as a positive exponent. So if I have a negative exponent, for example, I have 5 to the negative third, I'm going to rewrite that as a positive exponent by making it a fraction. I'm always going to write it with a 1 on top. Always a fraction, just write 1 on top, and then keep your exponent the same. We're just taking away the negative. So 5 to the negative 1/3 becomes 1 over 5 to the third. So it's going to be a fraction, or as you know, we can take our fractions, we can change them into decimals. And then I can evaluate it. 5 to the third means I'm going to multiply 5 times 5 times 5, which gives me 125. So I have 1 over 125. And if we wanted to, we could do the math and divide that and change that into its decimal counterpoint as well. I'm going to use the calculator to do that right now. And if we change this into a decimal, we get 0.008. So we could express a negative exponent either way. But I want you to get used to being able to at least rewrite it still in its exponential form and just know that's the way that it's going to work. And I specifically, when I talk about this, I want to look at powers of 10. This is actually going to be the basis for the next lesson, where we're going to talk about scientific notations where the powers of 10s will be important. So what I set up is kind of like the number chart here. You'll notice we've got the thousands, hundreds, tens, ones, tenths, hundredths, and thousands. So basically I was looking at this and writing each of them as their exponents. So we know that 1,000 is 10 to the third. 10 times 10 times 10 gives me 1,000. 100 is 10 squared. 10 is 10 to the first. If you'll recall, we talked about zero exponents. 10 to the 0 gives me the 1. Then what you'll notice is as you're working your way down here, the numbers are getting smaller. So what is 1 less than 0? Negative 1. Well, what does negative 1 look like as a decimal? It looks like 0.1. Why? Because it's 1 over 10 to the first, which is 1/10. That is the same way we would read this decimal, 1/10. Here I have 1/100th. Again, that's 10 to the negative second. And if you look, that would be 1 over 10 squared, which is 1 over 100, or 1/100th. So that's how we would write it as a decimal. So this is just a different way to express each of these numbers, but it still means the same thing. I just want to look at that because that's going to come into play when we talk about scientific notation. So the first thing I wanted to look at to be able to do is just simply writing our decimals as a power of 10. And what I didn't point out on the other board, but I'll point out here, is basically it's a matter of powers of 10 is how far we're moving the decimal. So if we look at this, I'm going to move my decimal 1, 2, 3, 4, 5, 6 spots. So this would actually be 10 to the negative 6. All right? Pretty simple when we're converting them this way. Here I'm moving it twice. So this would be 10 to the negative second. So if I'm looking at the decimal, basically I just need to count how many places do I need to move that decimal to make a whole number, and that becomes my exponent of 10. And it's the power of 10, so my base is 10. My exponent becomes the number of places I move to the decimal. So here we're just going the opposite way, 10 to the negative 7th. Well, that means I should have 7 decimal places, which means I need 6 zeros. And don't forget, because we still need our 1, and then my 1 at the end. So I need 7 decimal places. If you count 1, 2, 3, 4, 5, 6, 7, I have 7 decimal places. Here, negative 8, that means I should have 8 decimal places, which actually means I'm going to have 7 zeros before my 1. Okay. And again, I'm telling you at the bottom here, this is the beginning concepts for our scientific notation. We're going to need to know how to write things in scientific notation, but we'll talk more about that in the next video. So those are just if it's powers of 10, but I also just want to look at negative exponents and practice writing negative exponents too, which is what we'll do on the next board. So here it says evaluate That means I want to simplify it to its fraction form, and we'll leave it in fraction form. We could change it into decimal if we wanted as well. Either is acceptable. So the first thing I want to do is simply rewrite this as a positive exponent. That's my first step. So I know I always write 1 on top, and then I just take away my negatives. So this would be 1 over 3 to the first. 3 to the first power is 3, so this would be 1/3. If we change that into a decimal, it would become a repeating decimal, which means if I was going to use this in an operation, I want to use it in its decimal form, because if you try to use operations, if you try to multiply or something like that with a repeating decimal, you can't do it without using an approximation, whereas 1/3 would be the exact number. So we generally use the fraction there. All right, so again, here I want to first rewrite it so that it's a positive exponent so I can solve it. So it's always 1 over, and take away this negative, so it's going to be 1 over 4 to the third. Then I want to evaluate. What is 4 to the third? Well, it means 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So 1/64. Same thing here. First thing I need to do is rewrite it so it's a positive exponent, then we'll solve for it. So we always write 1 over the top of the same exponent, but now is a positive number. So instead of 6 to the negative second, 1 over 6 to the second, or 6 squared. Then we want to evaluate. 6 squared means 6 times 6, so it would be 1/36. All right, here what you'll notice is we're doing the operations. So just as a brief review, if you've forgotten about how to multiply or how to divide exponents, you can go back and rewatch those videos. We talked about that when we talked about exponents. But if you'll recall, when we're multiplying exponents with the same base, we add the exponent together and keep the base. So the first thing I'm going to do is I'm going to simplify this. So my base stays the same. I've got -5 plus -3, which gives me a -8. I'm not done yet because I want to evaluate it. So this is the beginning of simplifying it, but I need to evaluate it. So 2 to the -8 is what that would become. How would I write that as a positive exponent? Well, it's 1 over 2 to the 8th. Then we can do our evaluation. And here, what I like to do is I like to write out my 2's and then I kind of cross them off as I go. 6, 7, 8. Because 2's are pretty easy to multiply, so you can do this in your head. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, 128, and 256. And if you can't do that in your head, it's okay. You can do it on paper. But 2's are pretty easy. It's pretty easy to double things. So I just kind of write them out and cross them off as I go. So it would be 256. Just going to erase my doodling there so it doesn't get annoying. All right, so just make sure you're going through each of the steps. Don't try to do too much at once in your head. So again, here I'm multiplying. So I've got 3 is still going to be my base. I've got 3 to the -4th times 3 to the -2nd, which when I add my exponents, -4, -2, I get 3 to the -6th. Now we want to say, how am I going to write that as a positive exponent? Well, that would be 1 over 3 to the 6th. Then we want to evaluate, and this is where I'm going to cheat and use my calculator. And in another video, I'll give you a quick tutorial showing you how to use your calculator to evaluate the different things and just show you the different functions of your calculator. So 3 to the 6th is actually 729. So it would be 1 over 729, or if we wanted to express that as a fraction or as a decimal, we could. And if we calculator, I wind up with a rather long decimal. Barely fits on my board. But remember, just if you're changing fractions to decimals, divide the top and the bottom. All right, here you'll notice we're now dividing rather than multiplying. So when we're dividing, we still keep the same base. So my base is still 11, except now I am subtracting my exponents, which means I have -7 minus -6. If you'll recall, I would encourage you guys to write this out just so you don't get confused. I generally do it in my head. I'll show you the first one. Remember, when we're subtracting, it's like adding the additive inverse. So this actually gives me 11 to the negative first, which if we write as positive exponent is 1 over 11 to the first, or 1/11. So again, here we're going to divide. So I'm going to keep my same base. My base is still 2. We subtract our exponents. Negative 10 minus negative 5 leaves me with negative 5. Now I'm going to write it as a positive exponent so I can evaluate it. So it becomes 1 over 2 to the 5th. 2 to the 5th is 2 times 2 is 4, 8, 16, 32, 1 32nd. All right. If you have any questions, you can post them in the comments. You can email me. You can ask at class. If you're confused, go back, rewatch the video. If you need to, go back and rewatch the older videos to remind you your rules for multiplying and dividing exponents. Have a great night. See you guys tomorrow.